Hello students, thank you for being here. This video will cover the key concepts, but the real in-depth learning takes place during our live meet where you have the ability to ask questions and participate in deeper discussions. Let's cover the highlights of lesson 1.3, perpendicular bisectors. Please make sure you go to your weekly slides and open up the notes that you see here on the screen. So you will find that in this lesson, for some reason, the GeoGebra construction tools are not embedded within. So what I've done is in your weekly slides, I've put a link to the GeoGebra construction tools, and you'll see me navigate through that on split screen here in this video. So we're actually going to skip the first couple of warm-up assignments, and I want to start defining a perpendicular bisector. That way, as we construct a perpendicular bisector, you'll understand why we've chosen to do it in this way. So a perpendicular bisector of a segment is a line through the midpoint of the segment that is perpendicular to it. Something to remember is that a right angle is a 90-degree angle. So we're creating a line and a segment. That line goes through the middle of the segment and forms a right angle. Now, when we do this, we need to first find the midpoint of the segment. Now, we just learned in the last lesson that we can create congruent segments using circles and using the radius specifically of that circle. So we're going to start there after we're looking at an initial segment so that we can find the midpoint of that segment. The construction that we create will look something like this. So we'll initially start with 2 points and then construct a segment between them. Now these 2 points don't need to be horizontal from each other. They could be vertical, they could be diagonal, makes no difference. In order to find the midpoint of this segment, we need to create a few circles. We'll create one circle around circle A, another circle around circle B. So this is creating 2 congruent circles like we did in the last lesson, and each of the radii from the center to the edge of the circle on both of these are exactly the same measurement. That also happens to be true if you look at where the 2 circles intersect each other. Notice that from the center to the edge of each of these circles, it's that same distance. If we can create a scenario where we have equal distances from the endpoints of one segment to 2 other points, we can create a line going through those points and also through the original segment that goes through the midpoint of that segment. Now we've just created a segment of AB that has a line of CD going through the midpoint of E, making CD a perpendicular bisector. You will reconstruct this in your IXL homework assignment today. You do not have to draw the segments from A to C and B to C, but you will certainly need to draw the points of A, B, C, and D in order to fulfill the requirements in your homework assignment. As always, I want you to check through the glossary of your notes to be sure that you are familiar with your vocabulary. A common way to see how a perpendicular bisector is depicted would be in the way that you see on the left-hand side. The dashed line would be your perpendicular bisector. That box represents a right angle, proving that this is perpendicular to the line segment AB. And when you see the hashes here, it's trying to indicate congruency or equalness amongst the segment. So from A to this intersection point and from B to the intersection point are exactly the same measurements, indicating that that intersection point is a midpoint. All right, hopefully you are feeling comfortable with the recap of perpendicular bisectors, and hopefully you'll feel comfortable working on that homework assignment. Good luck.